Okay, let's get into the univariate analysis. So we're going to start off by looking at the distribution of the continuous features. As we've assigned the continuous features to a list up above, we're just going to loop through that list. So we'll be looping through total, HP, attack, and plotting the distribution of each one of those. We're going to use SNS displot, so Seaborn's displot, data equals DF, x equals feature, and that's the feature we're going to be looping through. We set a height of 4, an aspect of 2, and the color to make it, set the color to make it a little bit nicer. So let's plot those and look at the distributions of the plot. So we can see here, really important to understand the distribution of a plot. This is really very important in all data science analysis, is really understanding the distribution of each variable or each feature. So here we're looking at the total. We can see that they're semi-normal, a little bit of a right skew, but semi-normal. We can see here in AP, we have a more pronounced right skew, but we also have an outlier over here. In attack, not so much no outliers, but we do see that there's a little bit of a right skew, a little bit of a sway to that side, to the right side of the distribution. Defense, we can see that there is some outliers over here as well. We do have the right skew, which is a common trend in all of the distributions, but we can see here that defense has some strong outliers. In special attack, we can see that there is the skew. There doesn't really seem to be so distinct outliers, although we could define these as outliers. And there is still the right skew in the distribution, as we've seen in common with all of the distributions we've looked at. So looking at the special defense, we see that there is a distribution going off into the right, or the skew going off into the right, and we see that there are some outliers here for special defense. And then looking at speed, we do have an outlier, but not so pronounced, not so distinct as the above distributions. More semi-normal. There is a little bit of a skew, but even the skew is less pronounced than the other ones. So that's looking at the continuous variables, the distribution of the categorical features. And just to remind us what the categorical features are, we have a list of type 1, type 2, generation, and legendary. So we have to do this, we have to plot these a little bit different. We're going to loop through those just like we did up above. And we're going to go seaborn.count plot, data equals df, x equals the feature that we'll be looping through, and we're going to change the palette to deep. And we're going to do something a little bit special here. We're going to use matplotlib to change the x labels on the graphic to rotate them slightly because it gets a little bunchy, as you'll see here. Makes a lot of sense to have these rotated a little bit. So we're looking at the first one, type 1, and this is why we want to, if we don't rotate it, these will be overlapping and it looks a little bit messy. So to clean up our plot, we're using rotation of 65 degrees. So you can see here grass, fire, and the point to take away here is that water is the most common type, whereas flying is the most or the least common type 1. The most common type 2 is flying, and this makes me think that most or the flying types would likely be a secondary type. And type 2, and we can also see that bug and normal are the least occurring type 2 Pokemon. When we look at distribution of the generation, we can see it's roughly alternating. There's lots in year 1, in generation 2, less, more in 3, less in 4, more in 5, less in 6. And so it's kind of this alternating pattern, but there's not a clear increase or decrease. And then here, looking at the distribution of legendary, false, and true, we can see that there's a lot less true or a lot less legendary Pokemon, which makes sense. That follows with our understanding of what Pokemon should be like.